Thank you. Yeah, I know you just came out of Microsoft session, uh, so now you can really hear from what AWS been doing. AWS, have been doing machine learning for many years, right? We have SageMaker. So before that, I introduced myself. I'm Srinivas. I head the partnership organization for all ISVs. So that includes security, data analytics, um, networking like Cisco. So these are all my partners. I head it worldwide for all these large infrastructure partners. So IN is one of the partner solution architecture. We directly support PingCap. PingCap is our strategic partner. When PingCap came to United States, I think we met the PingCap and we liked the technology and we thought, like, how can we do something together? So what the partnership org does at AWS is we work with all these partners like Snowflakes, Databricks, Mongoose. These are all my partners. On PingCap, we build integrations between AWS native services and the partner solutions like PingCap. If PingCap needs certain capability, here we talk about Bedrock capability that we have, and they don't want to build that same capability, then we integrate our service with the PingCap, so they get a easier access to the machine learning capability they have. So that's what my team does for all these partners. Um, and one of the things I want to go with is our service Bedrock, right? Bedrock is our platform, a managed service, which hosts a lot of LLM models inside. One of them is Llama, and then we have Anthropic models. So Ian will go through many other models. So what we do is basically our service teams, our engineering teams, they vet these models and we tune them so that they will be very highly performant on the platform. So when you go and use one of these models, you just couple of clicks, you can install the model, and you don't need to worry about performance, security, or where the data is coming from, because all this managed service all taken care by AWS. So PingCap built one of the retrieval augmented architecture, which Ian will go over what that does, right? Using one of the models and Bedrock service. So that's all about me. Most of the talking will be done by Ian, but I will be around if you would like to know more about partnership org, how we integrated our services with PingCap, or what kind of strategic partnership we have. So I'll be here for any questions. Okay, Ian.
So hi everyone, my name is Ayan Ray. As Srini mentioned, I report to Srini, and I'm a generative AI partner solutions architect. I support all the AWS partners in everything related to generative AI. So before starting, first of all, let's first understand why are we here, right? And why is PingCap having a separate segment in the HTAP conference right for AI? That's because generative AI has taken the world by storm. That goes without saying. There has been, and this field is so frequently moving that there is practically a new innovation happening daily. Even a model has been launched today, and it's literally happening to do. It's literally happening every day. And I, as a solutions architect, I work with a lot of customers, right? And they often ask us, there are so many foundation models to choose from, and how do I choose which model is the best for my use case? They also often ask me, how can I move quickly and build and deploy my models and take it to production? And the most important question that I always face is, how can I keep my data private and secure while doing so? Now, Amazon Bedrock is a fully managed service from AWS that provides you a choice of high-performing foundation models from leading AI companies, along with a broad set of other capabilities that helps you to build and scale generative AI applications. With Amazon Bedrock, you can easily experiment with the foundation model of your choice. You can customize them privately and securely using retrieval augmented generation, fine-tuning, or continued pre-training. And you can create managed agents for performing complex workflows like managing inventory, booking tickets using managed agents. Now, Amazon Bedrock is fully serverless. That means you can do all of that without having to worry about undifferentiated heavy lifting of maintaining and managing your own infrastructure. Now, what models do we have right now? Like, for example, for companies, the biggest problem is since an innovation is happening every day. Now, it might so happen that by the time you complete development and you're ready to move to production, a faster, cheaper, or a better model is available. Now, you have two options. If you're a product guy, you have two options. Either you have an option to delay your product release and to lose out on a competitive advantage, which definitely you don't want to do, or you compromise on either your user experience or your margin. Now, with Amazon Bedrock, we provide an unified API. Now say, OK, model X is good, you are building with it, but today model X version 2 is good, and you simply switch the model ID and do so. Not to mention that if you are building with a new API, you have to again go through a whitelisting exercise, AppSec review, and whatnot. But now with Bedrock, it's already whitelisted. It has already gone through the AppSec review. It's just you're switching the model ID. Now, what models we have? We have Anthropic, Claude 3 models, 200K context window, leading in the generative AI space. All versions of Anthropic models are available. That is Claude 3 Sonnet, Claude 3 Opus being their most intelligent model, HiQ being their fastest model, and Sonnet strikes a right balance between Opus and HiQ. We also have Claude 3.5 Sonnet, and it's highly likely that once they launch Claude 3.5 Opus or HiQ, it will also be available in Bedrock right from the beginning. We also have Mistral, which has also created which is doing great in the space. We also have models from Meta. We have all versions of Llama 3, 450 billion context, and all the context windows are available. We also have AI21 Labs. We have Stability AI for image generation models, and we have our own Amazon Titan models. And there are like multiple different. We also have Cohere, which is also famous for their re-ranking model and multilingual support. Now, this one thing I want to double click on is this privacy and security aspect of Amazon Bedrock. First of all, we do not use any of the customer's data to train the original base models, period. Even when you're fine-tuning the foundation model, we create a private copy of the model, put it in a secured container, and that is accessible only and only to you. Your data is secured both at rest and in transit, and most of you who has been using AWS for long is using AWS for its commitment towards priority and to privacy and security. It is always a priority 0 for us. You can securely access the foundation model from your own virtual private cloud without traversing the public internet, and that has been possible because of its integration with AWS Private Link. Compliance, a big issue to take the models to production. We are compliant with GDPR, HIPAA, ISO, SOC, CSA. You can buy provision throughput, which is extremely essential so as to not to face any throttling or anything like that when you move to production. So you can buy reserved throughput, that is the input and the output tokens, and that is extremely beneficial for moving things to production or implementing your foundation model or generative AI applications in production. There are also other things which is not covered in the slide, but I'll touch upon. We recently launched Batch Inference API, where you can put the data. It's really helpful for maybe running evaluations on the model or running prompts in batch or at scale. So we also have that. We also have generative AI agents, where you can create agentic workflows using the models that support it. We also have Converse API, which is like a one API for all the models. You just switch the model ID. It also does prompt translation. That is, it optimizes the prompt for each model, and it also supports function calling or tool calling, as you might call it, for the models which support it. Presently, it is supported by Mistral models, Anthropic models, and Cohere models. I'll take questions after I finish my presentation. Thank you. Now let's talk about retrieval augmented generation, right? Now, there are many things where foundation models does really well, like text summarization, writing poetry, drafting emails, but there are few use cases where it tends not to perform really well just out of the box. Like, for example, we all know that foundation models are trained till a knowledge cutoff date, and when you tend to ask a question beyond that knowledge cutoff date, it tends to hallucinate. It also tends to hallucinate if you ask a question that it has not been trained on, that is your private data. That is when also it tends to hallucinate. But there are ways around it. One of the way to customize a foundation model is called retrieval augmented generation. So we are talking about TiDB and Bedrock together. So I might divide it as retrieval part is where TiDB can come in, and generation part is where Bedrock and the foundation models supported within Bedrock can come in. So retrieval augmented generation is a technique when you can retrieve or fetch the relevant context from your enterprise corpus, from your private data, pass it as a context to the foundation model for it to generate the response that is grounded and is aware of your private information. So that's what retrieval augmented generation is. The core aspect of foundation model and retrieval augmented generation, everywhere it is vectors and vector embeddings. Now, vectors are nothing but numerical representations of the data, like anything that has a magnitude and a direction. For example, you can represent anything like banana, right? Say I have 2 dimensions in banana, 1 dimension representing whether it's a fruit or not, 1 if it's a fruit, 0 if it's not, and maybe the other dimension is number of letters in the word, 6. So here banana will represent like 1,6 dimension. So each of the dimension in a vector represents a particular feature. Now, vector embeddings comes into play to preserve the semantic relationship. It is where you not only represent it as a numeric vector, but you also preserve the relationship between them. For example, let's take a second sentence. The dog ate the food because it was hungry. Now, what is it here? It can mean either the dog or the food. We know that it means the dog and not the food. But how does the model understand it? That is where vector embeddings comes into play. That is where self-attention mechanism comes into play, where you weigh each element of the token and compare it with everything else, and preserve the relative weightage of each of the tokens, simplistically speaking. Right? That's where it's preserved in the form of vector embeddings. All these are dense embeddings. There's something called sparse embeddings as well. Dense embeddings preserves the relationship, the semantic relationship really well, and that's where that's what we use, right? So the process, I'll come to the process of retrieval augmented generation soon, but there are models specifically designed to generate embeddings. For example, we have Amazon Titan, which generates embeddings where the dimension length is of 1536. It generates some max tokens that you can generate out of it is 8,000. So what you can do is you can pass your input text or your enterprise data through Titan embeddings, generate the embeddings, and store it in a vector store like TiDB. This is where TiDB comes into place as a place to store vector. Few different things which makes TiDB special is it completely MySQL compatible. So if your data is already in MySQL and you want to generate embeddings out of it, you can use TiDB to store the actual data and also the embeddings. That makes it easy, right? It's also fully serverless. It scales up and down according to your workload. And it also has a pay-as-you-go model, which can help you, right? You can pay on the basis of compute and storage only. So here, TiDB has introduced vector search capabilities. It's presently in beta. So the biggest advantage, in my opinion, is that you can have the data and the embedding stored in the same place. And if you're already on MySQL, if you're already using TiDB, now you can also store the embeddings there. And TiDB supports different mechanisms for retrieval, like the standard ones. Basically, how retrieval is done is based on a KNN algorithm. Like you search for K nearest neighbors, and there are different similarity algorithms that is supported. Simplest one is Euclidean distance, where you calculate the straight line distance, but it also supports complex algorithms like inner dot product and cosine similarities as part of it. So you can get optimized retrieval results when you are retrieving from TiDB as part of it. It also supports joins and queries, and it also has a columnar data support. So now your OLTP is supported, your OLAP is supported, and your vector is also supported as part of TiDB. This is how our retrieval augmented generation workflow works, and you can achieve with TiDB and various AWS services. So first of all, there's an ingestion workflow. Like you have your data in your PDF documents or in your structured data stores. You run an embedding model. You generate embeddings for that data, maybe using Bedrock and Titan embeddings. You store that data and embeddings in TiDB in a vector store. Now that completes the ingestion workflow. Now in query, while user supports a query or asks a question, you again pass that user input through an embedding model, like Titan embedding model. You generate embeddings for the user query. Now you have two embeddings, one set of embeddings that you have already stored, and embedding corresponding to the user query. Now you then do a similarity search between these two. You try to do a similarity search between the embeddings of the user query with that you have stored. That's where KNN comes into picture. It calculates the cosine similarity, most popularly used distance algorithm, and retrieves you the top K nearest neighbors, right? Like say top 5 or top 3. That becomes your context, right? And then you can pass that context to your base prompt. That is the query of the user. It is like saying LLM, hey LLM, answer me this question, but only on the basis of this context. If you don't know the answers, just say don't know. Then the foundation model gives the answer, which is more grounded, and it now knows the context from your private data. Couple of services, AWS services can also help here. End users, you can use build and web application. You can, for making the API call, you can use Amazon API Gateway. Amazon API Gateway can call AWS Lambda. AWS Lambda can call Bedrock. Obviously, it will have native integrations. From there, you can call the Titan embedding model for embeddings for the generation part, and then you can generate the embedding, and then you can go to TiDB to retrieve the context, and together with the base prompt, embedding of the base prompt, and the retrieved context from the TiDB, you can pass it to the Bedrock generation model, text generation model, for it to generate the context, and then you pass it back to the user. So we have prepared a demo. Also to mention that if you are, how many of you are working on generative AI these days? Good, good. So you might also be familiar with popular frameworks like LangChain and Llama Index. So both Bedrock and TiDB has built-in integrations with LangChain and Llama Index. Not necessarily you have to use those to build a solution. We also have native integrations, but just FYI, we also have integrations built with those popular frameworks. This is a demo we can show. We have prepared a notebook. I'll share the link of the notebook with you after this. Akshata, shout out for Akshata. Akshata built this demo. This is where we are showing how TiDB, you can establish a connection with the TiDB. You can invoke the model, and you can retrieve the context from TiDB. And yeah, unfortunately, I can't, but I can share it with you after that. Yeah. Because it's recorded, that's why. So this is where we are establishing a session, and we are doing a vector search, taking the result of the vector search, and then passing it to the foundation model to generate the result. But the code is there. I know it might be a bit too small. but the code is there. You can scan this QR code. It's a publicly available repo. You can also find code from other AWS partners and different AWS Bedrock samples. For any questions that you have related to this, reach out to me, reach out to Akshata, reach out to Srinivas. Would be happy to help you. This is me. You can connect with me, and I can share the URL with you. All right, then. Thank you. Thanks for joining.